Roadside safety would be great with wide, flat areas along the sides of the roadway. Then, ditches could be located far from the edge of the pavement, and vehicles would have a large recovery distance. Unfortunately, there aren't many regions like this one where flat roadside areas are possible. In the Southwest, where terrain is flat, roadside slopes can be easily graded to a safe shape. Unfortunately, mountainous terrains and restricted rights-of-way make steep roadside slopes necessary. Ditches must be located closer to roadway edges. Clearing the trees and cutting through rocks makes the cost of providing safe roadsides enormous. However, other steps can be taken with slopes and ditches to improve roadside safety. In this session, we'll look carefully at roadside slopes and ditches so that you'll be able to 1. Identify the areas of roadside slopes and ditch shapes that affect vehicle safety. 2. Suggest alternative safety treatments for slopes and ditches. 3. Describe proper and improper installation and maintenance procedures. Here you see the critical areas of roadside cross-section. The position of the hinge point at the top of the front slope. The steepness of the front slope. The toe of the front slope. The shape of the ditch and the steepness of the back slope. We'll look at what happens to a vehicle as it crosses each area, and we'll see how each area affects safety. The distance between the travel lane edge of a road and the point where the slope begins greatly influences safety. A steep slope located right beside the travel lane is not as safe as the same slope located 20 feet from the roadway edge. The greater distance gives drivers space to regain steering control before reaching the slope. When a vehicle travels over the hinge point, two possibilities can occur. 1. The vehicle can become airborne with all wheels leaving the ground. 2. It can roll over, either on its side or end over end. The steepness of the slope will have a profound effect on both actions. Ideal slopes alongside roadways are about a 10-to-1 or flatter between the travel lane and the hinge point. On the other hand, vehicles will become airborne at about 40 miles per hour as they cross hinge points that are 6-to-1 or steeper. Most front slopes forming a ditch are 6-to-1 or steeper. Rounding the hinge point will greatly reduce the tendency to become airborne. Drivers have more time to regain steering control with the increased roundness. Obviously, drivers have no control while their vehicles are airborne, so the hinge point should be placed as far away from the roadside as possible and rounded to reduce the possibility of vehicles becoming airborne. These 2 points enhance safety tremendously. Once vehicles pass beyond the hinge point, they're affected by the steepness and condition of the front slope in 3 possible ways. 1. Vehicles can roll over sideways or end over end when they land on the front slope. 2. Vehicles can skid sideways or in a circular motion as they travel down the slope. 3. Vehicles may not be able to stop or return to the roadway before traveling all the way to the bottom of the slope. The FHWA learned through roadside tests that vehicles probably will not roll over on slopes flatter than 3-to-1 at 60 miles per hour unless the slope is badly rutted. However, neither can vehicles return to the roadway on a 3-to-1 slope at 60 miles per hour. Instead, they will slide out of control in a circular motion. On slopes steeper than 4-to-1, vehicles will travel to the bottom before steering control can be recovered. As I said before, severely rutted slopes can cause vehicle rollover. A smooth, stable slope surface is a definite safety improvement for unshielded roadsides. Barriers should be considered on slopes steeper than 3-to-1, particularly if the toe of the slope is hazardous. All appurtenances on the slope should be safety treated. The impact of vehicles is more severe the steeper the front and back slopes of the ditch. The cross-section of the ditch also influences impact severity. High impact forces are transmitted through the front bumper of the vehicle if it digs into the back slope of the ditch. High vertical forces are produced when the vehicle suddenly changes direction from downwards on the front slope to upwards on the back slope. And the shape of the ditch influences both vertical and horizontal actions. The right combinations of front and back slopes and ditch geometry need to be selected to reduce both actions. Safety can be improved simply by regrading the ditch profile to a slightly different cross-section. Evaluation was made of computer simulation and vehicle tests on slide slopes of 4 basic ditch shapes. Of the 4 shapes, flat bottom ditches are the safest, particularly if they are wider than 8 feet. Rounding the corners of the flat bottom ditch increases its safety even more, but probably not enough to justify the extra construction cost. Vehicle impact in rounded ditches is more severe than V-ditches, especially for steep slope combinations. And V-ditches are less severe than narrow flat bottom ditches. If the ditch isn't traversable, all the other safety improvements made in a clear zone are ineffective. Of course, always check the hydraulic needs. Now, you can find complete information on ditch design curves in Chapter 3 of the AASHTO Roadside Design Guide. Unfortunately, roadside safety improvement projects are often completed in a piecemeal fashion. All the elements of the roadway and of safety features aren't coordinated. In the following slides that follow, you'll see individual site improvements. Many of them should be integrated into an overall roadside safety improvement program. The total safety plan needs to be considered instead of individual situations. Often, improving one factor may create other safety problems downstream or at a later date. Here, you see a ditch with 2-to-1 slopes that is extremely hazardous. It is far too close to the roadway for the steepness of its slopes. Installation of an underground storm sewer system appears to be the only way to improve the cross-section. In other cases, ditch cross-sectional modifications can be accomplished in combination with other maintenance activities. For instance, debris removal and/or slope dressing operations can result in a better cross-section. Converting V-ditches to flat-bottom ditches and using the material removed to blend drainage inlets into the existing terrain will create a more traversable cross-section. Rigid obstacles on slopes or in the ditch region, like you see here, can destroy the safety features of an otherwise traversable roadside. The primary hazards found on slopes alongside the roadway include sign supports, luminaire supports, curbs, and drainage inlets. So it isn't enough to give attention to the steepness of the slopes and the cross-sections of the ditch. The expected path of vehicles that leave the road also needs careful attention to be sure it's clear of rigid objects. Here, you can see an example of lack of attention to a clear area. The ditch was lined to reduce erosion and associated maintenance, but then the luminaire support was located right in the ditch lane. Here, the complete medium was lined and a traversable grate was installed, but the traversability is ruined by the fixed base support. Trees in the clear zone are also a serious hazard to vehicles that leave the road. The pressure to preserve as many trees as possible along the roadway is often in direct conflict with safety needs. Sometimes extraordinary steps are taken to protect a tree. Trees growing close to the edge of the roadway create both a safety hazard and a continuing maintenance problem. Even trees and ground cover bushes planted to stabilize a slope will require trimming or possible removal later. Small trees, which don't look like a problem when they're planted, grow to become large trees and large hazards. You've seen in this session so far that roadside and ditch treatments can greatly improve a road. Construction and maintenance forces can take the initiative to improve the safety performance of a highway by giving their attention to these 5 areas. You'll learn more about your role in creating and protecting a safe roadside environment in this next video.
The roadside environment is a very important part of the highway safety system. Run-off the road accidents and collisions with fixed objects account for nearly 30% of all motorized traffic fatalities. Even where hazardous roadside objects have been eliminated and a clear zone established, as was done here, roadside features such as ditches, erosion ruts, and edge drop-offs can be dangerous to the occupants of a vehicle which has run off the road. Highway Department personnel are responsible for identifying these potentially hazardous situations and eliminating them through construction projects or routine maintenance operations. The shape of a ditch must be properly designed and maintained. This will prevent an errant vehicle from digging into the soil on the back slope of the ditch, causing it to flip or come to an abrupt stop. Above all, a hazard must not be created in the process of solving another problem. This is sometimes quite a challenge. For instance, in order to reduce the number of maintenance cleanings, this ditch was cut deeper with steeper side slopes than the design specified and has become a vehicle trap, an accident waiting to happen. Getting hit with a tort liability claim after an accident occurs is a much worse prospect than cleaning the ditch a few more times a year. The design of a safe ditch is dependent upon the steepness of the front and back slopes of the ditch and, to a lesser degree, the shape of the ditch bottom. If the ditch has a front and back slope of 5 feet horizontally for every foot of drop, a ratio of 5 to 1, any one of the 4 commonly used ditch cross sections is fairly safe. However, the wide flat-bottom ditches and the V-ditch are generally safer than the round-bottom ditch. Round-bottom ditches tend to get undercut or to be dredged too deeply and turn into a bumper trap. Here. For front and back slopes steeper than 5 to 1, a wide flat-bottom ditch with a well-rounded hinge point is the best choice. If the hinge point is well-rounded, the vehicle is less likely to become airborne. If the flat bottom is about 8 feet wide, it allows the wheels to contact the ground and settle the vehicle on a horizontal plane as it follows the ditch line, lessening the chance that the front of the vehicle will dig into the back slope. The force unleashed when a vehicle digs into the back slope of a ditch is very great. It can cause a vehicle to come to an abrupt stop or go into a roll, resulting in a severe impact upon the occupants. Besides being safer, a shallow, wide ditch with flat slopes is easier to construct and requires less maintenance than a deep, narrow ditch with steep side slopes. Excess material should always be used to flatten slopes and ditches to make them safer and to eliminate the need for a guardrail. A log should be maintained of potential waste and borrow areas along a given corridor that can be used for this type of work. A simple side slope is safe when it is flat enough to keep a vehicle upright when going down the slope. A slope of 3 feet horizontally for each 1 foot drop is about the steepest slope which will keep a vehicle upright. When a large section of an existing roadside barrier is damaged or scheduled for replacement, slope flattening and barrier removal should be considered. It can be more dangerous for an errant vehicle to strike a roadside barrier than it would be for it to run down a flat side slope and onto an established clear zone. The flattening of the slope is not the only factor that must be taken into account to make a side slope safe and traversable. Another important factor is keeping the slope free of fixed objects. Sign and luminaire breakaway bases and drainage structure elements should be constructed flush with the ground line so that an out-of-control vehicle can easily traverse the slope and not snag on these devices. Upright head wall drainage structures such as these should be replaced with designs which blend into the slope whenever construction or reconstruction projects are planned for an area. Many things are considered in the design of a safe culvert end treatment besides water flow and volume. Among them, the approach direction and departure angle of an errant vehicle relative to the end of the culvert, the steepness of the side slope around the culvert, and the size of the culvert opening. The size and shape of the culvert determine whether a vehicle's wheel or bumper will snag in the culvert end. Large culverts may require pipe runners or grates perpendicular to the dominant direction of travel. For example, research has shown that culvert openings up to 36 inches in diameter can be safely traversed by both small and large cars. Therefore, in most instances, transverse culverts with a diameter of 36 inches or less could be designed to match the side slope and not require a grate. Transverse culverts greater than 36 inches in diameter would require a grate. Parallel drainage culverts, such as those under driveways, side roads, and median crossovers, can present a significant safety hazard because they can be struck head-on. These culvert ends should be matched to the embankment slope and have a maximum grate opening of 24 inches. The bottom bar or pipe in the safety grate should be set a maximum of 4 inches above the bottom of the culvert mouth. Embankment slopes which can be struck head-on by run-off-the-road vehicles should be constructed to a 6-to-1 or flatter slope. A 10-to-1 slope is desirable. Even better, where low water flows are involved, installation of a paved low-water crossing is often less expensive than a drainage culvert and completely eliminates the safety problem of the culvert end. Transitions from pavements to shoulders and from shoulders to side slopes must be smooth. Pavement edge drop-off is a potential safety problem when located immediately adjacent to the travel lanes. Pavement edge drop-offs can cause severe vehicle handling problems and complete loss of control. Pavement edge drop-offs can occur naturally as the result of drainage, erosion, and settlement, or as the result of traffic action. This is particularly true on narrow pavements, especially when combined with high truck volumes. Regardless of the reason for their existence, these drop-offs need to be eliminated to provide a smooth, safe transition, as well as to prolong the life of the roadbed. A highway agency should develop a plan to determine when and how the drop-off will be eliminated. When an edge drop-off occurs as a result of construction or maintenance operations, a plan to reduce the potentially hazardous drop-offs should be developed. This should be done prior to the start of operations. The plan should be strictly enforced during the actual construction work. This plan could include an item which requires the daily backfilling of the drop-off with a wedge of material on a 3-to-1 or flatter slope. Warning signs should be used in advance and throughout the treatment. An alternative method to reduce the danger of edge drop-offs is to place appropriate channeling devices and signs along the hazard. Maintain a 3-foot wide buffer between the travel lane and the drop-off. One of the best methods for handling edge drop-offs in long-term operation is the installation of a portable concrete barrier. With a concrete barrier, maintain a 2-foot buffer between the barrier and the traveled way. Proper treatment of the barrier end, such as a crash cushion, is required. The barrier should be properly delineated. The upgrading of unsafe ditches, slopes, drainage devices, and pavement drop-offs should be coordinated with many other maintenance and construction activities. To provide a systematic improvement, make routine inspections and keep accurate records of findings, comments, and recommendations. After the work is completed, add to the record a description of the improvement and when it was done. Good roadside safety makes a difference. It can change what might once have been a fatal accident into a minor roadside mishap. A high priority for all Highway Department personnel is safety. The design and maintenance of a hazard-free roadside makes it safely traversable for the drivers who, for whatever reason, lose control of their vehicles and run off the road.
You are the most important part of our highway system. As you've just seen, your performance can prevent accidents, save lives, and affect the safety of millions of people. In our next session, we'll look at other ways your work can make our highways safer.